Okay, in this video we're going to kick off a new topic. We're going to begin talking about arrays. And we're actually going to split the topic up over a couple of videos so we can start off simple and work our way up to more complex concepts. Now again, this is just an introductory 101 class, so we're not going to get too deep into arrays, but we're going to give you enough to be dangerous. So in this video, Logan's going to start out by first talking about what an array is. We're going to see the syntax for an array. We're going to take a look at declaring some arrays, and then initializing arrays. From there, we're going to talk about accessing elements inside of an array, and then we'll go on with some examples. So of course, with those examples, you'll have an understanding of how you can go about using arrays in your code. So that's kind of the whole idea. Now, starting off, Logan, what exactly is an array?
Well, an array is a variable that acts as an index-based container for multiple values.
An index-based container for multiple values. Let me pull the whiteboard up here, and let's see if we can kind of explain this. So in the past, when we had created, let's say, an integer called x, what we had done was more or less created a container for storing data that we can then come back to and access at a later point in time. And this container held integer, in this particular case, because of the declaration over here, it held integer data. So we couldn't go in here and put A, B, C. All we could do was come in here and put an integer value, like 15. So what you're saying is with an array, basically we have the ability to create a variable that has multiple compartments, if you will.
Exactly. You could almost say it's like a multivariable. It's a single variable name that can hold multiple pieces of data.
So if I was to come over here and do something like this, aha, now we could have another int, but this gets a little bit more interesting because we're going to introduce these square brackets. So now we have an integer array, so we're going to have multiple elements exist inside of this variable. So let's say that we call this thing, we'll say x again, okay? These aren't written in the same application, by the way. So here we've got x. Up here, of course, we also had x. And let's see if I can just keep making Photoshop jump up. I'm sure I can. There we go. So inside x, we actually have multiple compartments. 0, 1, 2, 3. And these are each the index of each of these elements. So you could look at it kind of like this with the square brackets around it. But the key thing is, here in x, I have the ability to store, in this particular case, 4 separate pieces of integer data. So I could store a 3 in this one, a 16 in this one, an 8 right here, and a 9 up here in this one right here. And of course, I can access any of these different compartments at any time and pull information out or put new information in. So that's just a very basic look. But the key thing to keep in mind, once again, an array is all about the creation of a variable, but a variable that is broke up into multiple compartments. And in this case, we've got 4 compartments. Now, when you create an array, you're always going to be declaring what type of data will be held inside of those compartments. We can't put an integer in this one, and I want to put a string in this one, and an object type in this one. Can't do that. Basically, we have to stick to the related data types. In other words, in each element or each compartment, we're going to have, in this case, all integers. Okay? So, are we stuck to only integers, floats, strings? No. We can create an array of objects if we want. So we could have a particular class, and we're going to say my class. Let's say that's what we call it. Then we can go in there and basically say my class, like such. And again, open and close square brackets, and then give it a name. And now what are we holding in here? Well, now we're going to be holding references to objects. Okay, but again, it's still packaged all nice and neat in this array, which, of course, to make everything look right, it's going to be called X.
Now, if you remember back to the Hyperion game, we used this technique to track rooms, to keep rooms stored in a grid.
That's right. And that's a really good point, because that brings us up to another thing to mention real quick, and that is there are a couple of different types of arrays. We have one-dimensional arrays, and we have multi-dimensional arrays. In this particular case right here, the example that I'm creating is a one-dimensional array, okay? Just one. Now, a multi-dimensional array could look like this. So now what are we dealing with? We're dealing with rows and columns. Okay, so that gives us a bit more flexibility. And like Logan said, we kind of introduced you to this concept all the way back in Volume 1 of the XNA Xtreme class with Hyperion because we needed a way to store our map in a sort of a grid. And this worked perfect for us. So we used a multi-dimensional array to store each of the informational pieces of our rooms. Basically, each of our rooms were stored inside these.
Right, it made a very convenient way to organize the data into a grid fashion.
Absolutely. So the key thing to remember, what is an array? Well, basically an array is a means of creating a variable that actually contains compartments. So it's not just a single place to store information. We have multiple compartments for storing information, but we have the convenience of working with the variable as just one single entity. So it's kind of like a tackle box, right? Surely those of you guys out there, some of you have gone fishing in the past, so here's a tackle box, right? Just a real quick one. And our little hinge is back here, and so now it's opened up. We all get the idea, that's right. And inside the tackle box, what do we have? We have a whole bunch of different compartments, right, that we store different lures, weights, etc. in. But we're able to take this guy, close it, and grab the entire thing and walk around with it. Very convenient, very easy. And this allows us to say, hey, here's my tackle box, as opposed to saying, hey, here, compartment A contains these leaders, compartment B contains these hooks, compartment C contains these weights, etc., etc. So very convenient way of packaging up a bunch of related data and toting it around. Okay? So that's a very quick look at what arrays are. Now with this, Logan, let's go ahead and jump back over into
Visual Studio.
I'm looking down here on the bottom for it. There we go. And let's go ahead and show them the syntax of it by declaring one.
All right, let's show the syntax and even begin with some examples. So what I'm going to do is start a new console application. We'll take a look at our first array. I'm going to jump into the main method of the program class, and let's declare an array. Let's say I wanted an array of integers. We could even use the X example and set up an array called X that holds 4 elements.
Okay.
So let's see how we would do that. We need to tell the compiler what type this array is going to be of, and I want it to be of type int. Now we're going to specify open and closing square bracket to indicate that this is going to be an integer array. Now we'll specify the name of the array, which I'll set as X, and to begin with we can leave it as that. That is in fact a valid declaration, just saying that X is an array of integer. We can build, and everything builds just fine. Of course we're not using X, but there were no errors.
Okay.
Now, when you had drawn this on the whiteboard, you had used the example of X holding 4 compartments.
That's right, but if we jump back over here real quick to the whiteboard, nowhere did I say that there were going to be 4 compartments in X. Where does that come from?
Well, this happens when we initialize the array. At the point of initialization is when we can say how many elements or how many compartments are going to be part of this array. So what I could do is jump down to the next line and say that X is going to be equal to a new integer array, only instead of leaving the square brackets blank this time, I'll put in a number. In this case, I'll put in 4 to indicate that I would like to have 4 elements in my X integer array. Okay.
Now, a very important thing to note, some of you guys might be familiar with languages that allow arrays to dynamically grow or change in size. And in C#, that's not the case. Once you've specified a size, that's the size.
Right. There's no way to take an existing array and resize it, add elements or take elements away. You would have to completely reinitialize the entire array and discard all of the information inside of it if you wanted to resize or if you wanted to change it.
Or create a new array and copy data over.
Exactly. Because we could reuse X. If later we decided we wanted 10 elements instead of 4, there's nothing stopping us from at some point later in time saying that X was equal to another new integer array, this time having 10 elements. Yeah. But if we had done that, upon doing this, we won't save any of the information. The initial 4 elements will be blanked back out to their default values, though we will have a new array now having 10 elements.
Okay.
But just to point that out.
All right, so now we have gone in there and we have declared an integer array named X. Now you've initialized it, so at this point, it's a value type that we're dealing with. Of course, an array, now I don't want to get too far above and beyond, and this is really a little bit more of an advanced topic, but an array really is an object. Okay, so that's just an interesting thing to keep in mind. But inside this object, we've got 4 different slots that we're going to be packing information, and that information is going to be value type information here, of course, because it is an integer. And with that, the default value type for an integer is 0. So at this point, you can actually access any of the compartments inside of X, 0 through 4. It's very important to understand that with arrays, the index is 0 based. So while we do have 4 compartments, it's 0, 1, 2, 3, and there's your 4 compartments.
Right, you always want to keep in mind exactly how the index is working. Like you said, the index is going to always be 0 based.
That's right.
Your first element is element 0, and all the subsequent elements increase by 1.
That's right.
By an offset of 1. Another interesting thing to point out is that there is no such thing as a sparse array in C#. That means that you can never have an array that would have maybe an element 0, an element 1, and then skip to element 5. You can't skip. The elements have to be sequential, or they simply always will be sequential.
Right. And as I was saying, the default types, basically everything is initialized in X, so each of our compartments in this particular case contain zeros. So you can say all value types get initialized to their default types, and if you were to create a particular class array of a particular class, then each of the compartments would be initialized to null.
Exactly, whatever the default type or default initialization of the specific data type happens to be.
That's right.
Now what we could do is go ahead and take a look at exactly what data is being held in the array right now before we go in and try to set anything. Let's look into this array and pull out a few elements. To do that, I want to display it on the console, so we'll begin with a console write line. So write line, and we want to write an element of X. So write line X, and then give it an opening square bracket to indicate the index we'd like. So let's take a look at element 0 first. Then close this off, close off the write line, and I'm also going to put in a console read line just to hold up execution. So here's our console read line. Maybe drop that down an extra space. And if we run, we should see whatever data is being held in element 0. Now, of course, this is an integer, so thinking ahead, seeing that these are going to be initialized, integers initialized to 0 by default, so we should see 0 printed to the console.
Very nice.
Now let's take a look and see what are in the other elements, that is elements 1 through 3. I'm going to copy this line and paste it 3 times, so we can look at element 1, element 2, and element 3. And we can see that all 4 elements contain 0.
That's right. Now what happens if you happen to go out of bounds, basically beyond the number of compartments that are inside of the array? So go ahead and paste that line one more time. And let's go ahead and access 4. Index number 4.
All right, if we attempt to access index 4 and run the program.
I hear the hard drive. And
so we're waiting, and we've caused an exception. We've actually caused an out-of-range exception.
That's right. Outside if you look right there in the pop-up, index was outside the bounds of the array.
That's right. We have only 4 elements starting at 0 that we give 1 through 3. So trying to access element 4 is saying that we were trying to get this 5th element out of an array that only has 4.
You said 5th element.
And I knew you were going to catch that, too. That's awesome.
An interesting thing to point out is this is actually a very common error to see. And I say that because often we use loops and variables to walk through arrays, and sometimes we just happen to forget to subtract 1 or whatever, and we end up out of bounds.
Right. We try to write a piece of code that piece of code's job is to figure out how many elements are there, but if we miss something, if our offsets are wrong, we try to go too far, then we'll end up with an out-of-bounds exception.
Exactly.
So certainly a bad thing that you'd want to avoid. When we get into looping, we'll show exactly how to find this number and how to avoid this in an automated piece of code. Of course, if you're hard coding it, then the only thing you can do is just make sure that the number that you go up to doesn't exceed the number of elements you've defined. So let's end this off. And
okay, so now we've taken a look at how we can go in and access. Let's take a look at how we can put something into one of these slots. So let's back up right before all of our write lines. Yeah, you're reading my mind. Excellent. Let's put something in, let's say index 2.
All right, let's put a number into index 2. Let's throw the number 15 in it. So let's say that x sub 2 is equal to the number 15.
Okay.
Now if we run, we have all of our elements, except element sub 2 is containing a 15.
That's right. Again, this just drives home the point that the index is 0 based, so that reads 0, 1, 2, 3.
So if by 2 you had meant the second element, that would actually be element sub 1 in the 0 based index.
And there it is.
So if we actually wanted the second element, not element sub 2, we would have to use element sub 1.
It's easy, guys. It's very easy to do.
Now let's take a look at something. Let's say that we had specific values in mind for all 4 of these. We wanted them to all be non-zero and all hold a specific number. Now, I would have to set these with individual assignment lines, which could start to get a little bit, what do you want to say, cluttered.
Yeah, you're just adding a bunch of unnecessary lines to your code.
So what if we knew right off the bat...
Well, hang on. They're necessary because you obviously want to initialize it, but they're unnecessary in the sense that there's a cleaner way of doing this.
Exactly. When you initialize the array, you're given the option of specifying the values that should be put into that array. And you can do that by adding curly braces onto the initialization. That means if I were to go back to the line where we said new int with 4 elements, I could continue that by opening a curly brace and then specifying those elements. That means I could specify, let's say we wanted the first one to be the number 2, maybe the second one to be the number 5, the third element to be the number 8, and the fourth element to hold the number 15. Let's just say we wanted those values. So we put all of those in, separated by commas, and we finish off the statement with a closing curly brace. Now if I take away my previous assignment and run the app, we see we have numbers stored in all 4 elements this time, 2, 5, 8, and 15, without having to assign them as individual lines of code, individual statements.
Very nice.
So that can be very convenient if you have a list of values in mind that you want to set up.
All right. Now, do you want to try showing them something other than an integer array? Maybe, how about a class?
Okay. We could do strings, but of course string is going to be just replace this with cat and everything will be fine. So, yeah, let's go ahead and show an example of what if we had our own type? What if we had declared some class, which is of course a type, and then we suddenly decide we want an array of those. We want to have many, and we want them all index-based. So just for example, I'm going to make what I'm going to call a wall segment class. Class wall segment. Let's say we had some series of walls in the games based on segments. And since this is just an example, I'm going to put in a very simple field, something like a public integer called height. Let's say that these walls can have height for whatever reason. So what we've just done now is defined a type. Now if we wanted an array to use this type, really everything is exactly the same as if we were using int. Where int is the type, we just replace the type with the desired type. That means if we wanted an array of wall segment, we could declare that as wall segment, open closing square bracket, and we'll name this walls. Now instead of ending off the declaration, what I'll do is I'll do a declaration and initialization on the same line here. So we could say that walls is equal to a new wall segment array containing, let's say this time, 10 elements. Now if we build, let's see, aside from where have I put, okay, yeah,
never been used.
So we have no errors, only a warning that it's not in use. So really it's as simple as that. Now of course we could turn around and if we wanted to use these, each of the elements are going to default to null since they're a reference type. So if we wanted to actually store something, we could say something like walls sub-0 is equal to a new wall segment.
Now think back, guys. Think all the way back to Hyperion. This should start looking kind of familiar here, even though in this particular case we're working with a one-dimensional array. This should look kind of familiar.
Right, so at that point we would have done stuff like setting up all the properties. So say walls sub-0 dot height, and then set that to some value, and
exactly.
There we go. Now an interesting thing to point out though, since let's say we wanted to take a look at a different form of initialization, with the value type we'd shown a line similar to this line, only done as an immediate assignment in the initialization. And you can do that same kind of assignment with the curly braces, even with a reference type. Now the key here is, what are we storing? Well, there's no literal for a wall segment. Instead we have to use new wall segment. But there's nothing stopping us from putting that expression inside of the assignment in the initialization, inside the curly braces. So we could say new wall segment for 1. Now I'm going to change the size of this array down to 2, just so I don't go way off the screen. And we could have another new wall segment. And then we don't need that line anymore. So we could build, and now we have an array that actually has wall segments in it right off the bat. So we don't have to worry about using one and it being null and causing an exception.
Okay, very nice.
So let's see.
I think that gives a really nice, quick overview of what they are. You want to put together an example?
Right. What would be cool now is to show an example of where this would really be useful. Because right now, even though we've just changed the rules from using names to using numbers to accessing them, otherwise, thus far, they all just look like more advanced variables.
Sure.
Now what I want to do is put together an example where we use the index as a sort of lookup to actually gain some access to some information. So in order to keep things clean, let me wipe out all of this example code and even wipe out the class itself since we're done with that. Now what I want to do is put together a small piece of code that will take in input key presses and translate them into a string.
Okay.
For this example, let's say we were making a Coke machine simulator where we have a series of buttons, let's call them buttons 0 through 3 or 1 through 4 or whatever you want, and we want those buttons to correspond to a flavor of soda that the Coke machine can dispense. So what I'll do is I'll begin with an array that holds a series of flavors. We'll store those as strings. So what I'll do is I'll make a string array called flavors, and we'll turn around and initialize that to a new string array with 4 elements. And then I'll go ahead and set those elements to be something like lime, cherry, grape, and cola. So we'll say that these are our flavors for the Coke machine. Now what I want to do is set up a loop that will continually check for key input. And when input is received, it'll try to, well, first see if that's a valid key, and then map that to a specific flavor. So let me write a infinite loop. We'll say while true, continue doing something. And what we want to do is first get some input. If we look at the console read key method, we can see that let me actually hover over read key for a second. It returns a console key info. That's the actual type we need. So before I go further, I could define that. We want a console key info variable, which I'm going to call key, and we'll set that equal to console.readKey. Now, readKey has an extra parameter that can be given. If I bring up the parameter list, we can see that we could give it nothing, or we could give it an intercept, which means whether or not it's going to show the key we pressed on the screen. I would rather have that suppressed, so I'm going to put in true.
Yes, that's true to not display the pressed key.
Exactly. That way we'll suppress that. We won't see a number being pressed as we type that in. Now, what I want to do next is I need to translate this into a number because, of course, the elements in an array are a zero-based index using numbers to address them. And what I'm going to get back from the key is, well, let's briefly look into the key itself and see what we have. We have key, which is a console key info key type. We have a key char, which returns an actual character from that key. And that's what's going to be most useful to us. The only thing to keep in mind is that the char, while it can be converted to a number, is going to be the character code for that key. So what I'm trying to get is a series of key presses where 0, 1, 2, and 3 return actual numbers. So let me write a little bit more of this out, and I'll show where I'm going with this. What I want to do is I want to find an index. So let's go ahead and define that. I'll define an integer called index. Now I want to be indexed to be equal to the code character for the pressed key. So that could be equal to something like cast_int for key.keychar. So take whatever character we have and get the character code out of that. Now the problem is the character code for the 1 key isn't actually going to be 1. It's going to be some other number. And we can find what that number is by bringing up the character map. So here we have a series of keys, or a series of characters, and we begin with 0 through 9 keys. Now if we look at 0, we can see that the code given is 30 in hex. But of course we're working with decimal as we're coding in literals. So what I'll do is I'll bring up the calculator and let's figure out what that is in decimal. So if I punch in the value 30 in hex, convert that to decimal, we have a decimal value of 48. Now what's cool is that just basically means that 0 starts 48 off the beginning of the character map. So if I subtract 48 from the given character code, we have our codes readjusted so that 0 through 9 are the actual 0 through 9 keys. So that means instead of storing the index as the char itself, we could say the char minus 48. That would mean 0 would actually be the number 0 held in the index variable. Much more useful to us. Now one final thing we should do before we try to look this number up in the array is make sure that it falls within bounds for the array.
Let's go ahead and just have it go ahead and right line out the flavor that they selected, but let's go ahead and leave it where we can crash it.
Okay, which actually happens more common than the safe way. You'll very happily jump in with any number being an index, not realizing that your array does in fact have some bounds.
That's right.
So let's just do the lookup first. We want to write out a flavor based on an index. So we'll do a console write line. We'll write out flavors and then the index given, so index, and then end that off.
Okay.
So let me build, make sure I haven't introduced any errors. Nothing other than a warning that the code never actually gets to the read line, which is fine. So let's run and see what happens. First, let's see if this lookup is working in any way, shape, or form. I'm going to press the 1 key, and we get the output cherry, which actually looks about right. Since lime was 0, cherry was 1, and 1 did in fact bring up cherry.
Very good.
That meant if we were to hit 0, we get lime. If we hit 2, we get grape. And if we hit 3, we get cola. Now what happens if we hit 4?
Boom.
We crash the program. We throw an exception.
Once again, index was outside the bounds of the array.
And also we have to be careful because all the other keys do in fact have a character code. So if I were to run and maybe hit the J key, that also crashes the program with index being 58 now. So that means we need to do some balance checking before we attempt to look up that element. And I'm going to do this balance check as a simple if statement. I'm going to say if index is greater than or equal to 0 and index is less than or equal to 3. So that should fall safely within our 4-element array. If that is indeed the case, go ahead and do the lookup for that index and write it out. If not, we'll just skip writing anything out, but we'll also skip the lookup and thereby not crash the program. So let's try this now. If we hit the J key, once again, we get no crash. If we hit the 8 key, no crash. But if we hit 0, 1, 2, or 3, we get valid flavors. Of course, 4, 5, 6, 7, 8 all do nothing.
Very good.
So that's just a quick example to show where an index-based lookup might be very useful and allow you to do things you couldn't do with simple variables.
That's right. So with that, that's pretty much going to wrap up the introduction to arrays. Again, in this video, we're just dealing with single dimension, so one-dimensional arrays. That's all. So basically, we have a variable that is simply broke up in compartments, and we reach each of the elements inside those compartments by using the square brackets and specifying which compartment we want to look in, starting at 0, since, once again, arrays are 0-based. And in the next video, we're going to get into some more interesting stuff, where we're going to start talking about multidimensional arrays and looping through them. So with that, that is going to wrap up this video. Thanks a lot.